Thank you for joining the October 15th, 2019 VOLTHA call. Just a reminder to everyone that these meetings are public and recorded, and we do post them to our YouTube channel after the meeting. So please be mindful of that during any discussions and presentations that we have on today's call. With that, we'll go ahead and get started for today. So first on the agenda is looking over new JIRAs, specifically looking at items not related to current brigades. So we'll cover that. And then also a brief update after that on a change we're looking at to our format for these meetings, and that will be related to the brigade updates. And then hopefully we will be continuing the discussion that we started last week on device and port state transitions and actions. And then if we have any all discussed JIRA items, we'll review those. And then finally on the agenda today, we have an item from Sarah for an update on our plans for branching changes. So that's what we've got on the agenda today. So going up to the first item, we do have a number of new issues. I'll see if it's updated since we came in, but the new ones since our previous meeting were 2034 through 2076 last I looked. And I had taken a glance at those, and as far as I can tell, all of them except for 2035 appear to be ones that would be associated with brigades, which means that rather than discussing them and reviewing them on this call, they would be covered during the brigade meeting updates. So I'll just jump over quickly to 2035. This is one that we have some ongoing discussion and changes related to discussions we had last week. And let me see if we've got Ken on the bridge. Actually, I don't see Ken yet. Okay, so this one right now, it's not targeted for a brigade, but I think we had some productive discussion last week. And likely we may need to bump this one up to an epic. So TBD at this point, we don't have an epic assigned to it. And I suspect it's going to become an epic on its own. Any questions on this item for today? Okay, then let me just do a check to see if anything else came in. We do have a couple more, and those appear to be unit tests tagged for stabilization, so those will be covered during the Stabilization Brigade calls. So I think through 2079, we are covered for the review today. Okay.
Is the unit test part of the stabilization?
Yes, so those are covered under the stabilization meetings right now, I think. I believe some of these, I took a quick look, need to assign an epic to them as, oh wait, we do have an, I don't know, those are tasks. I do need to map these into an epic, and I have to remember where we were putting the unit tests in terms of an epic.
Oh,
maintenance.
I think most of that stuff was just going in maintenance.
Okay, so we can do that after the meeting. Thanks, David.
And is maintenance part of Stabilization Brigade?
Yes, sir.
Okay. Thanks, sir.
You're welcome, sir.
Anytime.
Any other questions on the recently opened JIRAs for the group discussion today? Okay, then next, we had some talk with the G5 after last week's meetings, and we've decided to make a change to the format for the Tuesday calls here and see if that helps a bit. We had been doing brigade updates. We were trying to do that every week on Tuesday, get an update from every brigade lead. But what we're finding is that we need more time for discussion of the technical proposals that are on the table for because those need to be resolved so we can get the work done. So what we're going to try doing here is make a change. So we're not going to be doing the brigade updates on every Tuesday meeting. At most, it would be every other week. So we'll kind of see how this goes and see how it works out. And then the plan then is that we'll collect updates on the weeks where we don't have a discussion during this call. then we collect over email updates from the brigade lead, so we could provide an email summary instead of the verbal update that we've been getting on the Tuesday calls. So that gives us a little additional time on Tuesdays. We can cover technical discussions. We're hoping that will help us make more rapid progress. If you do have problems with how this is working on getting the updates, please let me know so that I can attempt to address your concerns. So the brigade leads, you are not on the hook today for giving a status update, but expect to see an email from me if I don't hear from you afterwards. I'll be reaching out to get updates from you so I can provide a summary over VOLTHA Discuss. Any questions on this change? Okay, and let me see. I don't think I see Ken on the bridge. Let's see. Okay, so I may not be able to cover this item here. Okay, unless we have someone else who can take the lead. So I was hoping we could continue the discussion we started last week. We were able to address some of the questions that Ken needed answered related to the proposal he'd sent out on device and port state transitions and actions. We didn't finish the discussion. We got a couple of the answers, which triggered that 2035 new user story in JIRA. But I was hoping we could continue that discussion today. Do we have anyone else on the bridge who would be willing to lead some discussion there, or do we need to reschedule this for a different time when Ken is available?
Just gave him a ping on Slack to see if he's going to
Okay.
join. Can we move forward to another item and come back if he is?
We can. This, I think, will not take much time because when I had checked last, and I'll just do a refresh here.
Yeah,
so
I think part of the problem is folks maybe not aware of the format change might think that that's typically a Thursday kind of conversation.
Yeah, it usually
now the goal is going to be, we're going to do this both Tuesday and Thursday to make the most efficient use of everyone's time. So yeah, if he may not be aware.
And I will take the blame here because I did not give him a heads up. I'm just used to him always being on my calls. So I will take the blame on this one.
It's after Thanksgiving lull going on in Canada right now. For those who don't know, yesterday was Canadian Thanksgiving.
Okay, thank you. I'd forgotten about that. So the all discuss items, the only one we have right now is 1975, and this triggered the discussion that we have that's going to continue on Thursday. And that's down here on transactions and having more discussion about transaction boundaries between the adapter API and the core and getting some clarity on what the definition of done will be for a transaction. And so I think this item, which is listed on VOLTHA Discuss, is actually going to be related to this discussion we have on Thursday, so we'll not plan to cover it today. Just a reminder to everyone, let me drill down here, bring it up so you can see it, that if you do have a topic in JIRA that you would like to have discussed on either a Tuesday or Thursday call, please pull in that all discuss label for it so that when I do the filter on the board, it will pop up on my screen so that I can bring it up for the following meeting. Okay. And
he did say he's joining.
I saw his name starting to pop up here, so I will.
Yeah, I'm here. Sorry about that.
I'm going to give you my apologies right now. So sorry I didn't give you a heads up. I just blindly assumed that you would be here, which I should not have done. So what I'd like to do, if you're available, is to continue the discussion on the document that you had in questions related to device and port state transitions and actions, since we got some answers, but not everything. So I was hoping we could make some more progress on that today. Does that sound possible?
I think that's possible. The only thing is, I think we kind of get to an agreement last time, but we can just go over it.
Okay.
Yeah, I think the big item is we are past the flows part, so we can finally get down back to the original question of states of ports and devices at various points when things are disconnected, unplugged, restarted, what have you.
Yes.
Yeah.
Oh,
Okay,
I guess I wasn't sure that we'd reached. Sorry, I wasn't sure we'd reached agreement on that in terms of, you know, what kind of request response in every circumstance we were going to have. Maybe I'm wrong. But okay. Well,
the agreement was on the at least the flow repush, autonomous repush, and then redoing decomposer to push flows to parent and child. That one was one that answered a fair number of questions, at least for me, about what to do about reboot and storing traffic.
Okay.
That one. Yeah. And a lot of the distraction was caused by that. And I purposely saying we're past that now. So now we're back to more the original question of, you know, the two fields, the device state and the port state, and then removing connection state, and kind of the original question of why we have so many state fields and what they mean, if they have meaning or they need to have their meaning changed to make more sense.
Yeah, I was thinking about something else. Okay, you're right. Okay.
Okay, so Ken, would you like me to bring up one of your documents on my screen, or would you like me to give you presentation rights? What's your preference?
No, you can bring up the document. That's all right, because I don't have it yet on my screen.
Yeah. So again, my apologies to you, Ken, and thank you for joining. And let me see if I have the right one. I'm thinking it's this one, the PDF. Let me see if I can make that a little bigger. Is that visible enough for folks? Do I need to make it larger?
That's great.
Okay.
So pretty much this document, we have gone over it. We have gone through multiple sections. I've updated it a number of times. Really, the questions that we had was about flow pushing to the devices. So that one we have resolved that. We can either go through each states. It's a request per se in the document, line by line, or if there's anything general that we want to discuss, we can discuss that too.
Let's scroll down a little bit and look at the line. I know you had some questions in here, and maybe that might be a good place to focus on.
Yeah, let's scroll. Let's first look at this table that I put in, because when we're talking about states, we're talking about certain states that can only be changed by the core and some by the adapters, and we're saying like admin state can only be changed by the core, and the adapters can only change the operational state. So this table specifies some scenarios where the core would actually change the operational state. It's pretty much when a device is pre-provisioned the very first time, and when we discover a child, we'll set it to discovered. And when a device is enabled, it will be set to activating, and when it's disabled, it will be sent to unknown. And whenever we lost connectivity to an adapter, then the operational state of those devices will be set to unknown. So those are really the only case where the core will have to change the operational state, which break a little bit the rules of the core does not change operational state. Yes, somebody had a question?
Yeah, this is sort of, I'm trying to understand why the admin state is changed to disabled when no when there hasn't been any explicit command to disable it. So my assumption is that admin state is always enabled unless someone explicitly disables it or then re-enables it, right? So
Yeah,
for example, the first 3 lines, I don't see any reason why the admin state is not just enabled by default.
Yeah, go ahead.
And the 4th line, when device is explicitly disabled, then I can understand that the admin state is changed to disabled. But when an ONU is first pre-provisioned, or when it's the child device, when an ONU is discovered, you haven't been told otherwise. So the way we've been working is that it's enabled until told otherwise, right?
Okay. Let me explain that to that a little bit. Julie, maybe you can give me presentation, right? So it's easier maybe for me to scroll through. Sorry about that.
And also, Ken, I've been asking you to help us out by converting this PDF into a Google Doc and have it in that design folder meant for device states. So if, is that okay? People can comment directly into the Google Doc then, right?
Yeah, that's correct. That's all right. So Saurav, before, can you see my screen?
I can.
Okay. So when you look at admin state here, in the current implementation, whether it's 1.x or 2.0, in terms of states that we have for admin state, we have unknown, pre-provision, activating, enable, disabled. So we have a lot of admin states per se, and we didn't have really a clue of how we were going to use all of them in all the different states. And we had operational state that was there was different ones. There was like discovered, enrichable, unknown, and also we had connection state. So we had a little bit too many states. So we had a discussion earlier over a few TST calls where we said that maybe we need to consolidate all those states to make them a little bit more clean. So what we agree on is to have only really 2 states. One is the admin state and one is the operational state. And any states of the device will be reflected by the combination of the 2 of them. So admin state will only either be enabled or disabled, and to reflect the situation where, for example, a device has been created and nothing happened to it. So we set the admin state to disabled and the operational state as pre-provision. This is like a very unique scenario where a device has been created and that's the state that we set it. And the whole point of the exercise was really to look at all the states and figure out like which one makes sense and which one does not.
So I'm in complete agreement that admin state should only be enabled and disabled, and the combination and operational state should reflect all these various states that you can be in. Okay. But admin state is very specifically only enabled or disabled, and the assumption is that things are enabled unless they're explicitly disabled. So,
and I think this is a behavior change too that might make the ONUs, or at least the child devices, consistent with the parent devices, the OLTs. Whereas a parent device, until it's explicitly enabled, it is disabled, right? When we add an OLT, we have to enable it. The change here would be if a child device or an ONU is discovered, it too would have to be explicitly enabled in order for it to further be provisioned. And we had a previous conversation about this where I think it was trying to mimic existing network equipment where everything is admin disabled until explicitly admin enabled.
Well, okay. But I've never understood the two steps of the pre-provision and enabled. Why is that necessary? Why is it not just pre-provisioned and that's it, right? I mean, it's like a one-step call, and ONUs come up enabled as well, right? Unless something higher up says that, okay, wait a minute, this ONU, I don't know what this serial number is, I don't know where it came from, I'm going to disable it, so I explicitly disable it, right?
So maybe, okay, so maybe we take it the other way then. Maybe just like how the children or ONUs are enabled unless told otherwise, maybe when the OLTs are added, they're enabled unless told otherwise.
Told otherwise, right? So it's just easier, right? Like when a switch comes up, everything is just enabled, right? Unless he explicitly wants to disable some ports, so you go ahead and disable it.
From a state machine in the core, it doesn't matter whether we start with enable or disable. But I don't know for adapters if that make a difference or not.
I think it's okay. I'd rather them both be consistent. I mean, that makes sense.
So today, when you create a device, you create the data model for the device. When you enable the device, that's when it actually makes contact with the adapter and the device. So if a device comes up enabled, that means the minute you create it, we're going to now reach out and try to touch that device?
Yeah, pretty much everyone does exactly that, right? You do pre-provision and enable right after it, right? I don't see the point of the two steps. And so if you make it consistent with the ONUs when things come up enabled, just do that, right?
Maybe it's configurable, right? Maybe, I mean, again, it's a feature. We could say, what do you want your default initial state to be? Disabled or enabled for all devices, and then the default for installations is enabled by default.
Ken, do you know the history on that one?
Really, the history of that was before we had a lot of admin states. So it was really to facilitate state transition. So like there was a state to say, like at the beginning when we create a device, the admin state was unknown, and the operational state was set to pre-provision. And then from there on, like when we enable, then admin state will go to enable, and then we'll do all the state transition. So there was no really reason why it has to be that way, and why it has to be a two-step process. But we believed it should have been part of a requirement somehow to make it a two-step process somewhat.
I really doubt that. I mean, because I've never seen anyone actually do a pre-provision of a bunch of OLTs, then go have T, and then come back and start enabling one of them, right? So,
you mean in VOLTHA or anywhere? I mean, to be fair, VOLTHA's not in production, so you can't say, I don't know what people's use cases are. But the API reflects two calls today, the GRPC API. So this change in behavior can be implemented, of course, but there's still at an API level kind of a two-step process, a create and enable, unless we're talking about changing the GRPC API.
Yeah, I'm just looking at the workflow for Turk Telecom. That kind of reflects that. The OLT goes through in a second enable call, and then the ONTs are by default enabled.
No, but that's just the thing, right? The workflow for Turk Telecom mirrored what was there originally for AT&T, and again,
right, but the workflow is reflecting.
The
workflow is a requirement, right? So
I suspect that workflow based on what VOLTHA already today, right? So
I agree.
I don't know what.
So the question to my mind is, are we talking about changing the API, or are we going to keep the API the way it is and just enable the workflow kind of in the code?
I would go for the latter. Keep the API the way it is, and just assume that things are enabled by default, and unless explicitly told to be disabled. It's consistent across OLTs and ONUs then.
Yeah, but should we make, because currently it's a pre-provision call, it's not an enable call. If we do a pre-provision call, are we going to make it configurable, like Matt said, where we're going to have a flag in the code to say well, treat pre-provision as enable or not? Or are we going to have another mechanism where we're going to, if we don't change the API, maybe pass in some metadata to say like, oh, okay, in this scenario, you can enable or not?
Okay. Honestly, I don't really want to complicate this so much, and neither did I want to spend so much time on this. It's just, let's make a call and move on.
Just one comment here. The API is not pre-provision. The API is create. So pre-provision is a CLI-ism.
Yeah, exactly. I mean, I would just say that it's a create call. Just go ahead. That means, just go ahead and enable it. And if somebody wants to disable it, they can explicitly do so. Don't put more complication of configurable identities because it's not necessary. Let's not complicate issues.
I think this has a little bit of history, right? AT&T requirement originally say we need to be able to pre-provision a device. And I think maybe most likely this is coming from that. So when you pre-provision something, when if the device is not there, which means you will not raise any alarm or any events, right? So I think I think that's the history about how this a two-step established. I think probably because of original AT&T test cases. So my question is, if everything is enabled as default, right? Will there be an event or alarm raised when the device is not there?
Well, in theory, when you call the enable call, we reach out and try to communicate to the device. So if we combine these two, create and automatically enable it, or automatically try to reach out to the device, there is an error when the device is not there.
And then when the device show up, would that error be cleared up? How often does
I can't answer how often it tries to retry to connect. I think it might go back to just say today. It might, if you try to enable a device and it can't be enabled because you can't reach the device, it probably transitions to the disabled state or an unreachable state, and it's up to a manual operation to try it again.
I think the OLT keeps trying. I think the adapter keeps trying forever. I think it goes into a backoff timer where it may wait longer between retries, but
eventually the API is going to time out.
Yeah, and then the loop in adapter will hit it again and try it, wait, time out, and just continue on until broken.
In the past, even the ONUs were brought up one by one, right? Remember when those expon CLI commands used to go ahead and we got rid of all that, right? We said that no, ONUs are coming, they're getting discovered, they're assumed enabled by default. If they are in the wrong location or they are in the wrong serial number, you don't know about it, then we'll go ahead and disable it. It's the same case over here, right? I mean, if you're sending the command to create it, the OLT, just create it and be done with it. And if it's not there, it'll, when it shows up, it'll enable. So it's not about
if in the adapter they're trying to back off loop to connect to a device, and if your workflow calls for a provisioning of 1,000 devices, you're not going to want 1,000 back off timers when you know those devices aren't there. So it depends what the requirements are for the workflow.
Would it be easier in this case just to say leave this behavior the way it is today, just so we can kind of call it what it is? So in OLT, it is enabled by default or disabled by default until somebody explicitly calls enabled. Just leave it the way it is. And then ONUs happen to just be enabled by default. I don't know if that hurts or helps things for you, Ken, but I think it at least gets us past this and we don't have to change anything for now.
Yeah, let's move on. I agree with what Matt said.
The thing, in any case, we have a lot of changes to make. because just changing the states, admin state from 5 to 2 or operational state and remove connection state. So there would be a lot of changes going around no matter what. So I suggest we do what's right, because we don't want to come back and revisit it because of the amount of changes that we'll have to do in any case.
So can we get clarification on use cases? Because I think that's going to help define what we need to do as right.
My problem is the use cases are dependent on the way things have been, and if we were still doing that, then we would be bringing up each ONU one by one. What I'm saying is that we change things to make operations simpler, and so if we make all decisions based on what has happened in the past,
I agree with that statement. The question is there a use case for the carriers that say, I'm going to pre-provision N number of devices when I know they're not there yet? And yeah, I want them to, maybe when the device shows up, to automatically enable, but that's a different use case and model than what we've been talking about. And if that's the use case, then there might be other changes that we need to consider.
Okay. So maybe we just reach out, move past this right now, and reach out and ask the operators again.
Okay, just one final statement on this one. If we look at this as I'm trying to draw, don't yell at me if I draw a chassis based. So you enable the control card, right? The control card is active now, and all the line card, if we treat it as an individual, OLT device here. So when the CBA pod is coming up, I don't know. I think when I'm drawing something, I pre-provision this line card, this chassis, and then when I insert the line card into the slot, I don't need to enable that again, right? Sorry. Okay, well let's discuss a little bit later. I think let's think about use.
Wouldn't it inherit the parent's state? So if the OLT is enabled, the ONU is enabled. Like an ONU is, I'm outside of the hardware side of this, but to my understanding, an ONU is a passive device. You don't actually turn it on and off in some sense. It's just, if there's traffic to it, it's passing it.
I don't think we're discussing about the ONUs over here. So, let's move on. I'll reach out to the operators to see if there is a need for the pre-provision call and if automatic enable is fine or not.
Okay, so if we still have to go through two-stage process, do we leave it as disable pre-provision, or we make it enable and pre-prov?
Yeah, so let me reach out to the operators and see if they have any opinion about this that is not totally colored by past experience. But
okay,
and I'll come back and answer that question.
Okay.
Hi, this is Amit. Just one point on that. So when we pre-provision a device, so that would mean pre-provision some data on it, right? So typically that would be some configuration on the device. So we would want to change something, but not let the device go active yet. So, but in this case, in our case, I don't think in the pre-provision state we can change some configuration in the device or not. So does that have any significance to what we are talking about right now?
No, in pre-provision state for the OLT, the actual hardware hasn't been contacted yet, so it would purely be just changing the core's view of the initial device configuration, basically the IP and port of the agent.
Yeah, pretty much in the core during prov, we just save the data. That's it. There's nothing.
Yeah, so
yeah,
right.
that's what I question, that if I am not able to modify the device configuration or change anything. So it's only if the IP and the port, then what's the point of pre-provisioning only the device IP and the port if I can't do any other configuration of the device?
Right. I mean, I think in traditional hardware, maybe you can do pre-provision, then you can do 100 other things, and then you go ahead and enable it. I'm making sense of that, right? In this particular case, there aren't 100 other things that you're doing, right?
Right. My point is not that we really need a two-step provisioning process or not, but if customers are going or operators are going to pre-provision, and today, if you enable a device that's not existent, there's essentially a backing timer that keeps retrying and retrying and retrying. What I'm suggesting is our implementation doesn't fit the use case, operator use case, if they pre-provision a bunch of devices that aren't there. So I'm okay with automatically enabling, but there's also some implementation change in the adapters because I don't want to start 1,000 back-off timers. I'm going to implement it differently if I expect a large number of devices not to exist when they're enabled and I'm waiting for them to show up versus, I'm assuming the minute you enable, the device is there. And I think that's a key difference in our implementation.
Yeah, I think if you enable it, you want to bring it into service, right? I mean, if there's no point in enabling something if there's, it's not going to be operational, right? I mean, what's the point of that? You're going to generate a whole bunch of alarms that no one's interested in.
Yeah, I think maybe it's not so much about bringing enable further back sooner in the process. It's bringing pre-provision to being later just in time in the process. Like, don't pre-provision anything until you know you're ready to actually enable.
Well, but you can pre-provision before you enable. That's the whole point, right? So,
sure, but I guess my point is that pre-provisioning ahead of time, if there's nothing there, really doesn't accomplish anything. You could just assume pre-provision milliseconds before the enable happens, as if it's a new line card plugged in right then and there, and it appears and is ready to go. Why pre-provision anything if there's nothing there to pre-provision?
But again, right? So potentially you will add a device, and then the technician will go out to provision them. So you don't have to synchronize any steps, right? You have the technician installation got involved on this one.
Sure, but I mean, there's nothing saying they have to go into an API, set up one thing, and then physically plug in something and then finish setting it up. You could just as soon plug in something and then set it up. Right, the pre-provision step, I mean, it sounds like it's a carryover from, configuring something ahead of time, just to say we configured something ahead of time, when in reality, it doesn't matter if it's in there until we're ready to enable it.
Yeah, it is more like an EMS functionality instead of the hardware device functionality. Yeah. So I'm debating on these two right now. Right?
Yeah, I mean, it's the difference in EMS to chassis versus chassis to line card, right? I think chassis to line card, you don't tell the chassis ahead of time, get ready, I'm going to plug something in slot 5. I have no idea what it is yet, but I hope you're ready, versus something got plugged into slot 5 and all of a sudden it's there, ready and enabled. Right, an EMS may pre-provision polling for a device versus a chassis may be ready to take on that device as soon as it's plugged in.
So the chassis come up, has to send out some signal back to whatever, call home. I don't know.
Well, and that's the thing is the EMS technology is kind of one of the things where we may pre-provision an EMS to pull a VOLTHA pod as represented by everything that's there, but the VOLTHA pod representing a chassis and line cards, there's no reason to tell the EMS that, oh, there is going to be a line card ahead of time here at some point. The line card will show up and then it's there, it's enabled, which to me gets back to the moment you're ready to enable is the moment you want to plug in your pre-provision information, because that's the only time it matters.
Yeah, but it may be the wrong line card, right? I mean, if you don't pre-provision it, then you can't say whether it's the right thing or the wrong thing, I guess. But I think I agree. It's more of an operations style question, I guess, right?
Okay, so please let's move on. I'll talk to some of the operators and come back with a final answer.
Okay, so if I go further in the document, have a question there, and we talked briefly with Matt, and I believe Amit and Girish a little bit about that. It's when we disable an ONU, currently in the core will send a disable to the ONU adapter and rely on the ONU adapter to do the disabling and set up all the states. There's calls that actually goes to the OLT adapter to tell it that an ONU has been disabled. So the question is, do we need that notification? And if we do, is it a notification that needs to be done after the ONU adapter has responded, or should it be something that's sent to the OLT adapter first, then the ONU adapter?
So it does need to happen. So the scenario here is the ONU can, delete itself. The adapter can delete the instance, but there are complementary resources on the OLT adapter that also have to be freed up. So parent has to know. In terms of the ordering, technically, I think it could go either way. The suggestion I have was when creating the ordering is OLT adapter sets up what it needs on the OLT hardware, and then proceeds to tell the ONU, create yourself, child device detected. Would the disable or delete take the same path? When we're disabling a child, would it be better, or deleting a child, would it be better to tell the parent, let the parent clean itself up just in the same way it did for create, and then proceed to tell the child to clean itself up?
The parent device need not know if the child device was disabled, because we don't free up any resources. The resources are freed up only once you delete the child device.
That's right, delete. So disable, so maybe disable, this isn't the case. Disable for the child, I was confusing the two. Disable for the child is purely a question of the ONU disabling its resources and not having to tell the OLT anything.
Yes, because
in this case, in this case, really what the ONU is going to do is it'll disable all the UniPorts and then disable the ANI, the ONTG. There's a parameter in there to say, disable all the GEM ports, something like that. In the disabled child case, there's nothing to tell the parent. It's up to the child to do everything.
Okay, so for disable, we just ignore it?
I think for disable...
ONOS is going to withdraw all the flows as well, right? So that's going to take care of whatever the OLT is going to need to do.
Yeah, as a side effect. So what will happen is the disable today, if we tell the ONU disable today, it'll disable the ANI, it'll disable all the UniPorts. All of those UniPorts will now be reported all the way up the chain as down. ONOS will see the unis are down and then proceed to withdraw or do whatever ONOS needs to do with a port down, whether that's pull flows or not pull flows. But it gets reported up to ONOS either way.
Yeah. So in this case, we don't need to send a notification to the OLT adapter, correct?
Not for disable. I think we're good with disable being individually addressed to parent or child, depending on what you're disabling.
Yes, agreed.
Okay, cool. So let's move on. I'm not going to address the next one because those are just remove APIs. It doesn't really matter. We talk about the reboot. During the reboot of the device, should we repush flows?
No.
Any flows that are in the core? And I think we kind of agreed last time not to do that, correct?
Correct.
Right, yeah.
Reboot will take care of itself by UniPort states being changed and ONOS doing whatever it needs to do either way.
Okay. And we have another one about the device state update. This is any change on the device that goes from any states to enable and active. Should we send flows down or not?
I think this is similar to the other one, where if the enabled or disabled changes, ultimately it's up to ONOS and how it views port states to decide whether to push flows or not push flows. I think this is the same thing.
Okay. So whether it's an OLT or an ONU, will do the same thing. We're not going to push anything. Correct?
Right. We'll let the natural workflow of ports, logical ports going down in ONOS, and letting ONOS decide, in all cases, reboots, disconnects, reconnects, enables, disables, letting ONOS ultimately decide whether what gets repushed or not.
Agreed.
Okay. Are we all in agreement with that? Okay, cool. And here's a case where we are talking about delete device.
Okay.
And I believe this is the one that the parent needs to know about, correct?
Yes, this is what I thought we were talking about earlier. Yes.
Yep.
If it's the OLT being deleted, I think right now it's or the parent being deleted. The parent automatically being deleted automatically calls the core automatically calls deleting the child or the children, right? Is that how it works today?
Currently, yes, it does that.
Okay.
Well, it seems kind of catastrophic, though, right? I mean, it's like if I accidentally delete the OLT, everything's gone. I got to rebuild it again, right?
Yeah. Well, some of it is kind of edge casey, where if I delete it and I want to re-add it, I want to make sure the re-add still works. Again, there may be just some scenario where an operator may need to do that. So it's really just housekeeping, making sure the housekeeping is done right.
Yeah.
Deleting a child. Go ahead.
I was saying, so I guess in the case where I go delete an OLT, I haven't touched any of the subscriber database, right? I mean, if I add that OLT back again, it should automatically recover, right? Using the authentication of the serial number, etc., right? And then the subscribers' flows will get pushed on the ONUs as they're discovered. Right. So I guess it's not really that catastrophic. You'd have to really go and add all the subscriber information again.
Actually, if you delete the parent device, it's gone in the code.
But the configuration in ONOS is still there. And I think that's the difference is if you delete the device from VOLTHA and then proceed to delete the device configuration from SADIS, then it's really gone. Then there's, it all has to be repopulated. But in the case where the ONOS SADIS data is still there and the device ID is deleted and then re-added and it has the same device ID or OF DPID, from the point of view of ONOS, it's re-added again and will proceed to provision based on its SADIS data, just like it did before.
So everything in ONOS is referred by the DPID, right? Which is pretty much the MAC address of the OLT.
Right. So again, the use case here is kind of tricky, where if we delete one and then add it back, but when we add it back, it's a different DPID. Let's say a hardware swap. For whatever reason, an operator wants to delete it and re-add it for a hardware swap. It may come back with a different DPID, but again, it's up to whatever northbound workflow to now move that DPID from, and its associated SADIS config, serial numbers and whatnot, to the new DPID and a new serial numbers so that you can add it back again. If the DPID is the same, then northbound doesn't know the difference.
Right. I mean, the question is, are we going to implement or need a kind of hardware replace or swap type capability so that we can tell the systems, A is B when you see it, just remember that.
Yeah. It may be that it's more driven by northbound. It may be that, a northbound, workflow and SADIS has to, in addition to deleting a device, or maybe not deleting a device, maybe just changing its OFID is enough, but then fix all the associations in ONOS.
So if the OLT one failed, right, we have to replace it. So what is the workflow now? Because the MAC address will definitely change, and we don't want.
Yep. So the serial number of the OLT will change, the MAC address will change. What will happen is that kind of just walk through it. OLT1 dies. It's ODN, still plugged into OLT1. Somebody goes out and plugs in, connects OLT2, but hasn't moved the ODN yet. So step 2 maybe is fire up OLT2, and then at the same time, the workflow now either moves or configures OLT2 to have the same status configuration as OLT1, except swapping the serial numbers. And then finally, they move the ODN, and then when they move the ODN, all the ONUs will go down, and then they'll come back up again if they haven't already. ONOS will see the new flow, see the new ports, and push the flows.
Right, but I've also given it the same IP address, right? I mean, was that
for the OLT? I think we should assume not, right? Maybe we assume that it gets a different IP.
Well, when I create the OLT, I'd say what the IP address is, right?
Yeah. I guess I'm saying is when the new one is brought in to replace it, it'd be nice to be able to have that one set up and ready without having to do kind of the IP swap in the dark. That way, maybe you could drain stuff off the dead one. It may be that you want to get the new one set up, it gets a new IP, and you're running both of them side by side, and you're moving PON port by PON port to get folks back online again.
Both scenarios could happen, right? So maybe some people want to replace it and then to have everything the same.
Yeah, but
and potentially the other one.
Sorry, go ahead.
Or bring up one as a separate IP address and then move everything over. So they're two different use cases or two different scenarios.
Yeah, but I'm saying, so for an identity within the abstract OLT, you still have to connect to the same port on the switch, right? I mean, otherwise it's not the same slot.
You're talking about the aggregation switch now. Okay. Are you?
Yeah, so if I replace an OLT in the SIBA model, I have to disconnect that broken OLT from the slot that's on so the ports on the switch that represent slot number 1 or 2 or whatever, right? I have to plug in my replacement OLT into that same slot.
So yes. How about this? Let's say for the purpose of this discussion, since we're just focused on VOLTHA deleting the device, OLT device, VOLTHA deleting the device should clean up after itself completely, regardless of what northbound needs to sort out and how it needs to sort it out. So I agree, this is a good discussion, we need to sort it out, but again, it's more now in the realm of SIBA, aggregation switch, and workflows, and less about VOLTHA just being told delete the device.
Yeah, that's correct. I'll agree with that, because in any case, it's not a problem that VOLTHA can resolve, it's a northbound problem.
Yep.
And just to check, are we at a good breaking point for today? Because I need to give Saurav a few minutes for our last topic.
I think we made pretty good progress so far. Ken, what do you think?
I think pretty good. Like I think maybe the last point that we already talked about last time was about PON state update. That's where we said that we'll change the flow decomposition for trap flows so that those get sent to both parent and child, and that will take care of subscriber flows as well.
Okay.
Correct?
Yep. How about we maybe save the last few just to be sure for next Thursday? I just want to make sure there's an awful lot of red in there and make sure I understand it. So to be continued for the last ones, I think.
Okay, cool. Okay, up to you, Julie. Thanks.
Okay. All right, Saurav, can I give you presentation rights now?
Yeah, please. Thank you.
Okay.
And so, Ken, based on our discussion today, if you can just upgrade your document and move it to the Google Doc, that'll be, and share that location with everyone so people can further comment and look at it.
Sure, no problem.
Thank you. Okay, so in the last 5 minutes, I just wanted to take 5 minutes to give you a little bit of a history of where we were and where we are going and some changes that we brought up. If you look at the history of VOLTHA in 2019, we had the 1.x as well as the 2.x, and in Q1, sort of two parallel activities were started, right? We did the tech profiles and the bandwidth profile work as part of a brigade in 1.x. And initially, I took a lot of flack from a lot of people saying, why am I doing this in 1.x? But there was a very good reason to do it, right? Because 1.x was stable, it was functional, and it could be built upon. Whereas 2.x in that time, we didn't even have containerized adapters. So Matt started that work in parallel of containerizing a Python adapter and integrating it with the 2.0 core. The next thing that happened in Q2 is that we took what we had with 1.x and created CBA 2.0. We found a number of issues with BAL 2.6, but that's why we called it the CBA 2.0 release. Based on, and on the 2.x work, Radis started the work for porting things to the Golang OpenOLT adapter, following the work that Matt had already done with the Python one. Okay, around that time, a few other things happened, right? For one thing, David brought up in a Berlin meetup that there is much that is wrong with 2.x, much that is broken with 2.x. And then David, Sean, and I discussed at ONF that there is a need for doing things in a stabilization brigade, or to work on the basics. Things should come up, and when things go away, it should come back up properly, and so on. At the same time, there was an ONF board meeting that stressed that ONF should take responsibility for, more responsibility for VOLTHA, and have that be brought into production according to the operator's needs in 2019, 2020. So two things happened from that. For one thing, the Stabilization Brigade was created in early Q3, and a Tiger team was created to learn about the operator's needs, what gaps we have, what schedule they want it in, and what kind of resources they can commit for creating these deliverables. So meanwhile, in 2.x master, based on the learnings of the BAL, the work that we had done over here, which took 4 months to sort out, within a month or so, Radis was able to then put on the Golang OpenOLT adapter the tech profiles and bandwidth profiles work. So it justified the work that we had done on something that was already stable and then could be ported over once the 2.0 work was ready. Imagine if we had to do all of this down here, right, for the first time. So at the same time, the learnings from BAL 2.6 and CBA 2.0 alpha required that we move on to BAL 3.1. Even the BAL 3.1 work was started with 1.x master because, hey, that was stable, that was functional, so we had something to work on. So there was a lot to say about, having stable branches where we could build new features or test new things coming onto it. Nevertheless, the Stabilization Brigade was born. We branched out into VOLTHA 2.1 to do work on stability while we could still bring in new features into master. And then the Surge team was created out of the Tiger team work, and especially these resources that were committed. So it was understood at that point that, yes, this 2.1 branch won't have all the features that you need for production. So it wasn't about production. It was not even about scalability. It was really just about having things be stable. And then in the future, we should be able to create a 2.2 branch, which would include all the stability work, would be feature complete, and would scale to the operator's initial production needs. So that's what we would have as long-term stable. With that approach, our delivery plan was something like this. Yes, we already have 2.x master where new features could go in, and the stabilization branch where we would be fixing things so things become stable. I ignored the direction of the arrows. What happened was that bug fixes actually go into master and then get cherry picked into the 2.1 branch. Okay, whoops, sorry. So, and then everything would have this test framework and a set of tests that would be applied to both the new features as well as the bug fixes, right? And that was the focus of the Stabilization Brigade. Now, there is a lot of the pros were that yes, we do believe that this would work. It does parallelize the efforts, but then there was this pain of having to cherry pick between the master and the stabilization branches. Nevertheless, we thought that this would work. But the reality is that instead of looking like this, what it really looks like is that, okay, the new features have been slower to come in, right? We got a number of features that we thought were 1.7 parity into the 2.1 stabilization branch already. And the new features, they are coming in now, but the stabilization branch has been around for a couple of months. what has actually happened is that there is a lot more work that is going on into the 2.1 stabilization branch, making it making these cherry picks over pretty painful, right? And the test framework is almost there. It's being worked on. It has been there in one form or the other, but the test coverage is only now getting started, and it'll be a while before we have decent test coverage. So the thing is, it's a really hard case for us right now to prove the value of this two-branch strategy. It would have been an easier case to make if 2.1 was closer to being stable, like 1.7. So we could do the things like tech profile, bandwidth profiles, BAL 3.1 development, all against something that is already stable, as opposed to 2.1, which is going to require a lot of work to make it stable. And so at the same time, this cost of maintaining these two branches is becoming higher. It's currently pretty high. The G5 did meet yesterday to evaluate this strategy, and our decision is that right now we probably we branched out too early, right? There's so much that is going on over here that needs to be cherry picked over from one branch to another, that the decision was taken that, okay, you know what, I think branched out too early. So let's drop these cherry picks to 2.1 right now and focus really just on master. Second, let's tag frequently on master. So if the need arises in the future to branch out of master for the same reasons that we actually branched out in the beginning, the need arises in the future because of frequent tagging on master, we should have a much better idea that if and when we do branch out for whatever reason. So that's where we are today. That's all I had. I just wanted to give some history behind some of the decisions we have made and some course correction that we are doing right now based on the reality of where new features are, where all the work is going in, and where the pain exists. So David already brought this up in the Stabilization Brigade call. If you weren't there, I'm just saying the same thing, but giving a little more history and background of the way things have been going. Any questions? I know we are over time, but so that's all I really wanted to share.
What does that mean? What does that mean for 2.1? Is that still continuing on, or basically that's over and everything's on master now, or what?
Yeah, that's right. So 2.1 is for now. If someone has interest to maintain 2.1 going forward, they are really welcome to do so. It's just not something that we will be monitoring.
And so what's the stabilization work, I guess?
The stabilization work is just going to happen in master at the same time as new features are going to come in.
Right. So basically we were expecting to have a lot of churn with new features and bug fixes at the same time, but we haven't actually had new features.
Yeah, they've been delayed coming in, but I think there is now one patch in Gerrit right now from Gamze regarding multi-TCONs, which is in Gerrit right now, but that is one that would qualify as a truly new feature.
With respect to stabilization, basically, the thought is that because things aren't changing quickly, the original concern was that things would be changing all the time in master, and so it would be hard to stabilize while it was changing. But it hasn't been changing very quickly, and so we haven't gotten the benefit of having a separate branch.
Yeah, that's fair. But David, do you want to add anything?
Yeah, that's absolutely part of it. The other part of it is when, at least in my mind, when the branching of 2.1 for stabilization was conceived, the idea was there was a release at the end of that, right? There was a target that we were going to hit, and after the Stabilization Brigade was actually formed, the target actually became, you know what? It's not just a stabilization release. It's going to be stabilization plus these new feature sets. So the end target that people would deploy would be including these new feature sets. So in my mind, not only what you said, Kent, in terms of churn, we haven't seen, but the issue is, from my mind, came, well, what is the value in testing of just focusing test on something that isn't what's going to be deployed? Isn't it more value if we focus on stabilization and test in that train that is going to be deployed, i.e. the master with all the new feature sets. And as even today, when we've introduced the end-to-end sanity test, as well as additional unit tests that we've done so far, you know, why don't we just focus on that and make sure that any code commits coming in, new feature or otherwise, pass a certain threshold, so that we don't get that kind of instability in the master branch in the first place. That makes sense?
Makes sense to me.
A quick question on Helm charts. We just did a Helm chart release like last week, and our rule was to go with the 2.1 image if it exists. If not, go with the 2.2. Should we re-release that Helm chart to point to all 2.2 images?
Yeah, I think so. Also, I think we still are going to want to pursue the what they call the incubator versus stable Helm chart path, like we see in other projects. If we ever want to release Helm charts pointing at, you know, I don't know, unstable or like when the new BB-Sim was introduced. You know what I mean?
Yeah, I think so.
Okay, that's all I had. Any other quick questions?
Okay, I think we're done for today then. Thanks everyone. I appreciate everyone's willingness to stay on a few minutes over today. And we'll go ahead and wrap up today's call. I'll go ahead and stop the recording.